A lot of people spell it Nickola, and that is not correct, and he was very quick to point that out. The other thing I want to point out, I've got 7 books up here, and I had to dig through 7 books. Thanks for Mel for 2 of them that he loaned us for this program. And without all those books, it wouldn't be what it is tonight. But first thing I would like to do is just try to bring you up on who this guy was. And let me tell you, there's so much out there that by especially the Tesla Memorial Society and the International Tesla Society, and just Tesla cults that are running around the country today. They claim that he invented radio, that he invented wireless communication, he invented radar, he invented x-rays, he invented the transistor, he invented a death ray, he invented spark plugs, he invented free wireless power, neon and fluorescent lighting, the laser, robotics, vertical takeoff and landing aircraft, cosmic ray motor, photography, lighting systems, anti-gravity, and golly, he was quite a guy if you listen to all the cults. What I'm going to try tonight is to give you a little bit of an idea of what I could find out about this guy and what my feeling is about him, and that's probably to some extent, you know, my feeling. I want you to know that. But okay, let's first talk about the man. And so what I'd like to do is just give you the first about 25 years of his life and tell you basically who he was. Well, that's a little out of focus, but it can't change. Let me just tell you real quick who this guy was. He was born in 1856. He was born on July the 9th or the 10th. He was born at midnight in a thunderstorm. And the midwife that helped his mother deliver told her that he was going to be a stormy kid. She said, no, he's a child of light. And as it turns out, she was right. The next thing that I'd like to point out was that he was born in Croatia, which today is Croatia. At that time, it was part of Yugoslavia or Austria Empire. And his father was an Orthodox priest, and his father was determined that he was going to be an Orthodox priest. We'll get into that. He had a brother named Dane. Unfortunately, his brother was an older brother, and when Nikola was born, his older brother was 7 years old. And when Nikola was 7, his brother was killed in a horse riding accident. So and Nikola always felt like that his brother got the attention because of the fact that, you know, he passed away and the family was that way. This young man started school, was doing very well. Unfortunately, when he got into high school, he contracted cholera at age 17. And he came very, very close to dying. And his father, who had been absolutely determined that he was going to be a priest, finally told him that since he knew Nikola wanted to be an engineer or wanted to be in electronics, he finally told Nikola that when he got well, that he could go to college to be an engineer. Well, let me mention one thing about Nikola. What really got him interested in electricity was, of course, back then houses were lit by candlelight, and So it was normally very dark in the house. Well, he found out when he rubbed his hand about the back of his cat that he could get little sparks to jump. And that one thing right there inspired him more than anything else to get into electricity, because he asked his father, what is this? What's happening here? And his father said, that's electricity. He said, well, what's electricity? And his father says, I don't know. And so Nikola was determined to find out what electricity was. He did go to engineering school in Austria, actually in Prague, and he was an amazing student, to put it mildly. He could memorize a whole book and repeat it back. He spoke 8 languages by the time he got to college. He could actually do integral calculus in his head, and the professors would accuse him of cheating because he was capable of doing it that way, and they couldn't believe that anybody could do that. He was age 19 when he got to the engineering school in Prague. Unfortunately, by the time he was about 21 or 22 years of age, he got involved in the college gambling group, and he started gambling, and before long he had lost all of his college money. So obviously he had to drop out, and believe it or not, even though he got several honorary doctors, he never finished college. When he dropped out, he started looking, well, what can I do with myself? I need to make some money. I'm broke. So he went to Budapest and went to work in a telephone company, mostly as a draftsman, but also they found out that he had hands-on experience with motors and things. And by the way, let me mention about a motor. One of the professors in college, when he was really studying and learning about motors and electricity and everything, had brought in a motor that was common in that day, and basically it was a DC motor that had a commutator and brushes, and usually they use carbon brushes, and when you ran this motor it sparked, and not only that, but the brushes wore out, and not only that, but the commutators had to be resurfaced every once in a while. And Tesla took that in as he was learning, made up his mind, there's no reason to do this. Why take DC and convert it to AC to make the motor run? Because the motor really only needs AC to run. So keep that in mind, because that's coming back up here very shortly. In Budapest, the telephone system was basically DC. He learned a good bit about generators, DC generators, and about DC circuitry and things like that. And this was in 1881 when he was age 25. The Budapest thing didn't last very long. He didn't make the kind of money that he thought he would, and one of the supervisors there at the telephone company realized that they had a very smart young man working for him, and he recommended that he go to work for the Edison company in Paris. And so our young man took off and went to Paris, and found out that Edison also was hung up on DC, but he hung around Paris long enough to solve some of the problems that they had with their lighting circuits, but he got involved in something that also followed him a good bit, and this was arc lighting, and I'll come back to that in a moment. Again, he was discovered by a man named Batchelor, who was the head of the Edison Machine Works in Paris, and Batchelor said, this young man is going places, we need him in the U.S. And so he recommended that age 28, Nikola Tesla head to the U.S. So in 1884, with a letter from Batchelor saying, I know two great men in my life. One of them is Edison, and the other one is this young man. And you need to have him come into your company and do what he can do for you. And that's the way, so we have covered the first 28 years of this young man's life. And he is now, hopefully, where he can really take advantage of what he can do. When he got to the U.S., he went to work for Edison. He met Edison right away, and he had a real bad experience. What happened was Edison was having problems with some DC dynamos that he needed to get fixed, and so he promised Tesla that he would give him $50,000 if he could fix those dynamos. And of course, Edison felt like there was not a chance in the world that he would get those dynamos fixed, but he did. And not only did he get them fixed, but he actually replaced some of the iron in the armatures with a lighter weight iron, but actually made a better magnet. And he really did a lot. Well, he went to Edison to get his $50,000, and Edison said, "Good grief, young man, you don't realize that in U.S. we make jokes." And he never got his money. And that was the end of his association with Edison. He left Edison right then after about a year, and unfortunately ended up actually digging some ditches for about 3 or 4 months just to make enough to feed himself. But he really and truly began to do some of the things that he wanted to do. One in particular was he was determined to get rid of the commutator on a motor. He was determined that that motor should run without having to have brushes and commutator and all the problems that motors had. But the only way to do that is on AC power. And up to this point, basically with the telephone company and also with Edison, all he'd been exposed to basically was DC power. So he needed to get somebody that was interested in AC. This is the way he tied up with a man named Westinghouse. And let me show you one thing here. This was the was his first attempt at an AC motor, and even though the patent says February 1896, he actually designed and filed this patent in 1887. And so in 1887, not only did he file this patent, but he filed patents for generators that would generate AC. When it was discovered that this young man was able to do this, the AIEE, the American Institute of Electrical Engineers, found out, about these patents and everything. They said, "Good grief, we need to hear from this young man." So in 1888, they invited him to come and speak to their group on AC and AC motors and doing away with commutators. As you'll notice, this motor does not have a commutator. And when he came and talked to them, they were very impressed. And one particular person was George Westinghouse was at that meeting. And when Westinghouse, who had already gotten started generating some alternating current, some AC, when Westinghouse got to hear this young man and about the motors and everything, he approached Tesla and told him that he would like very much for him to come to work for him. And not only that, but he wanted to buy his patents. So they sat down and started negotiating, and they ended up, in today's dollars, this young man now was just not even 35 or 36 years old. $1.4 million for his patents. $1.4 million for the patents. And better than that, $48,000 a month in salary. $48,000 in today's dollars. So all of a sudden he was very wealthy. And the interesting thing was that he really felt like, you know, he had the world by the tail. He moved to Pittsburgh, moved into a hotel to live, and became an employee of George Westinghouse. I wanted to show you this here because this is a quote from Tesla saying that if you're inventing things, if you're an inventor, if you're interested in inventing, then forget all the other things of the world. Forget food, forget women, forget everything. And he forgot women his entire life. How he did it, nobody, as I showed you the first picture, he was a very handsome young man. He was 6'2", weighed 152 pounds. So you can tell he wasn't a big heavy guy, but he was very good looking. He was a very dapper dresser. He was just a very attractive young man. Okay, now he's working for Westinghouse, and he's interested in AC power and AC motors and everything, but that was not sufficient for Tesla. He had to do other things in his laboratory that Westinghouse had provided for him, and so he got started trying to do something different, and he came up with the idea of the Tesla coil. Have any of you ever built a Tesla coil? Okay, a Tesla coil is actually a resonant high-frequency transformer. And what, as you can see over here, he's supplying AC to this transformer here, which has an iron core. But then he adds a capacitor to it, and he's got an inductor here, which is an air inductor, and then in air coupling here, and then the secondary of the coil, which by the way is tuned almost by straight capacitance, allows him to get a very high turns ratio, but also a very high frequency. And in fact, what the AC over here could be as low, it was in his case, it was 133 hertz, but it could be as low as 50 or 60 hertz. And all it was doing, like a pendulum clock, when this circuit went into resonance here, it'd just pop it every once in a while just to keep it resonating. But it was resonating with as much as 500 to a megahertz, 500 kilohertz to a megahertz. And when he got this to resonating that high, you can imagine what was actually taking place. Okay, this circuit and this is what his claim to radio was. And if you think about it, this is the tank circuit that we all use in our radio transmitters, exactly like that. And actually, you turn it around the other way, and it is what we use in our receivers to receive our transmitters that we build. So that was the claim that he had to inventing radio. And he, as you can tell, this was 1891, and Marconi hadn't even sent a signal across the English Channel at that time. So that's why he felt like, and by the way, the SG, in case you didn't pick it up, is spark gap. And all the spark gap is doing, it's acting like a switch. So that when the voltage across the capacitor is high enough, then the spark gap quenches and you very quickly start over. So that's what keeps the resonant circuit in resonance and keeps it at a high frequency. Okay, The Tesla coil was very popular. In fact, Marconi actually used a Tesla coil, or the exact what a Tesla coil is, to build his first transmitter. And it went from there. Okay. Back to Westinghouse. I have been in this building, and it's absolutely beautiful. It still exists today as a museum. It was built in 1893 as a Columbia exhibit or a Chicago World's Fair. It was the 400th anniversary of the discovery of this country, and so that's they were honoring Columbus when they built it. But the one thing that they did, they wanted to have some kind of a lighting or electricity exhibit. So they set up a separate building and called it the Electricity Building. It was a fairly good-sized building. And they put out bids for people to actually bid on lighting the area. Well, GE, which originally was Edison GE, made a bid to try to get it, and they put out their bid was $600,000 that day, and it'd be millions now. Westinghouse came in because they were going to use AC, and they had a whole lot less copper in their bid. Theirs was $399,000, and they did get the bid. And believe it or not, when they lit this thing up, they lit it up with 200,000 incandescent lights. 200,000 incandescent lights. This is part of the generating system that they had set up. You can see it says Westinghouse alternating current switchboard, and it was really a significant thing if you think about it, because back then the whole city of Chicago didn't have 200,000 light bulbs in it. They had 200,000 right here in this electrical area. And by the way, they even had fountains that they lit up. Westinghouse had a 45-foot water fountain that they lit up with a floodlight at that time. So it was really something significant. Well, Tesla had to get his 2 cents worth in. So he set up a Tesla coil exhibit, and what he did, these are like fluorescent light bulbs. That's exactly what it is. But if you'll notice, there's no wires attached to it. He is standing in a huge RF field, a huge radio frequency field of about, I think that one was about 600 kilohertz. But it was in thousands and thousands of watts that he was creating with his Tesla coil. And he could stand there with a bulb like that, and the bulb would glow in his hands without any wires attached to it. And people, you can see these people are just absolutely amazed. Not only did he do that, but he had displays of his electric motors. He had displays of anything that he had worked on up to that point. And by that point, he had about 20 different patents that he had already been given. So he was really getting a lot of attention. Again, let me point out, he's a nice looking young man. Women went crazy, and I was hoping there'd be some women here, because that is a direct quote from Tesla. And the women probably wouldn't like that one. Okay, the electrical exhibit that Westinghouse put on at the 1893 World's Fair was such a success that the next thing that Tesla had worked on, Westinghouse had worked on, and a whole lot of other people were considering was building a hydro plant at Niagara Falls. And what they wanted to do was they wanted to build when they put out the request for people to bid on this thing, what they wanted to do was they wanted to electrify the city of Buffalo, New York, which was 25 miles away from Niagara Falls, and they wanted to electrify it. So obviously Edison bid DC, and but he was going to have to have an auxiliary plant here, there, and yon, and the cost would have been almost unbelievable. Well, what Tesla and Westinghouse did, they put generators in at Niagara Falls that were working at 20,000 volts. And then they would send it over high tension lines to Buffalo. And they were able to get a significant amount of energy with very little loss into the city of Buffalo, New York. And it was absolutely unheard of at that time. So they were they definitely won the bid. This is what they were able to build. And by the way, most of that is still there. And of course the generators, I'm sure, are not the same ones that were in there at the time, but that is the first hydroelectric plant in the world was built right there at Niagara Falls. One thing interesting about that, Tesla as a kid was playing with little water wheels, and he told his uncle that one day he was going to come to the U.S. and he was going to put a giant water wheel at Niagara and generate some power from it. So he thought about it even that far back. That's kind of interesting that he thought that far back with it. Okay.
They only recently turned off the last of the generators they installed.
Oh, really? Okay.
In the past 10 years or so.
I knew it was fairly recent. I wasn't sure there were any.
25 hertz. That's why there was industries that were depending on them supplying 25 hertz up until just very recently.
Okay, Tesla's next big thing, and he blew everybody away with this one. He built, and believe it or not, in 1898, Marconi hadn't even sent his signal across the Atlantic Ocean yet, but he built a radio-controlled boat. And at Madison Square Gardens, he had constructed a lake, or actually a big pool that was big enough for him to run his boat around. And he had dignitaries, even had the president come to see this boat that he could control. And the way he controlled it with different frequencies that he was able to get to do different things on the boat. And what he was hoping to do, he was hoping to sell the idea as radio-controlled submarines or radio-controlled torpedoes or anything that could be radio-controlled was his idea. And believe it or not, before the term robot got out was many, many years. I thought this was kind of an interesting quote here, and this was after he built his robotic boat, that he was determined that robots were going to be a real important thing. And if you'll notice, he says in the 21st century, I think we're in it.
I think we're here now.
Okay. Believe it or not, it was 1924 before the term robot was even used. And so he was way ahead of his time on that. All right, in 1899, he got run out of his laboratory in New York because he was making so much noise, creating so many things that had happened. And by the way, even though they couldn't pin it on him, he actually burned down a hotel that his laboratory was in 1895. I mean, literally burned it to the ground. When they did the discovery on the fire, though, they found out that it actually started on the floor below where his laboratory was. But, and by the same token, he had already made the building shake with his so-called resonant oscillator that attached to a steel beam, and he'd already created artificial lightning in the building, and he was not too welcome. So John Astor, who, by the way, was the richest man to die on the Titanic, had a lot of money. He also owned the Waldorf Astoria Hotel, which Tesla moved into. But he bought some land out near Pikes Peak, actually at Colorado Springs in Colorado. And so Tesla in 1899 moved his operation out to Colorado. If you'll look, the tower here is 200 feet tall to a 3-foot diameter ball. He had originally planned to use a balloon, but he couldn't get enough balloons to haul what he was trying to haul up with the wire attached to it also. But let me tell you, in that barn right there, and that's what he called it the barn, and that barn right there was one massive Tesla coil. I mean, a huge monstrosity. And he said, and I guess I got to believe him, that he actually at one time had generated 100 million volts out of this Tesla coil. Now, admittedly, this is a time-lapse photograph. This is him sitting, reading a book. And but it is a time-lapse photograph of the energy that he was releasing. The thing that gets me on all of this is the amount of RF that he exposed himself to. As part of his display, even at the 1893 World's Fair, he would stand in an RF field that was so strong that he could hold his finger out and an arc would jump from his finger over to a steel plate. Or he could get his hair to stand straight up, or anybody else's. And of course he was lighting light bulbs, just holding them in his hand with no wires attached to them at all. But you can imagine the kind of energy and the kind of voltage that he was dealing with to get that kind of arc to take place. It was substantial.
Is this the Tesla coil over here on the left?
This is the Tesla coil.
Oh.
Well, and this, what is over here is what the tower is attached to, but he's actually generating energy between the two of them. He didn't have a big round on that one, so I don't know that.
Well, it looks kind of like the primary.
It looks
kind of like the primary.
That's possible. That's possible.
That thing in the very upper left-hand corner looks like the capacitance hat.
Yeah.
That was on top of
But
the
see, this also could be, well.
There's another one back there too.
I haven't seen an actual drawing of that, but the Colorado Springs operation was actually only lasted 2 years, and by that time he was trying to get back to New York because he really missed it and wanted to get back. But he drew so much energy one night in his testing that he destroyed the AC generator at El Paso Electric Company that was supplying the electric, and they had made an agreement with him to supply the power free until he destroyed their generator. And he ended up having to take a crew down and rebuild their generator to get the city back with lights again, because the whole city was out. Okay, let me tell you, Tesla, after 1900, went back to New York. He went to live in the Waldorf Astoria Hotel, and he wanted to build, now that he had found out what he could do in Colorado, he was still hoping to send AC power wirelessly anywhere in the world free. And what his idea was he was going to get the Earth, he determined what the resonant frequency of the Earth was. And I forgot exactly what it was, like 8 hertz or 15 hertz or something like that. He was going to set the Earth into oscillation at resonance, and therefore anybody anywhere in the world would be able to have free power at that point, just with a simple little device to take power because of this resonating Earth. And that's what he was working on here in Colorado. He claimed that he actually was able to get 200 light bulbs to light 26 miles away. There was not anybody that witnessed that, unfortunately. Okay, let me give you another little thing here. He got to know some very influential people in his lifetime. One of them was Mark Twain. The reason he wanted to know Mark Twain was he had memorized 2 of Mark Twain's books when he was in high school. And he was so enthralled with the story of Mark Twain, or Mark Twain's stories, that he wanted to meet him. So this was actually in Tesla's laboratory, and Mark Twain is holding a bulb, which is, as you can see, is lit up. So you can imagine he was in a fairly strong RF field at that point, and the energy was huge. Okay, here we go with his big project. This is Wardenclyffe on Long Island. J.P. Morgan was interested after Tesla came back from Colorado and talked about his free electrical energy and free wireless all over the world. J.P. Morgan was interested in investing, and he gave Tesla $150,000, which would be $6 or $7 million today. And Tesla started building this huge, monstrous tower that he drove. He had a large path with a circular walkway down 100 feet, and then he went 300 feet below that to get a real good, what he thought would be a good attachment to the Earth. And then he had the big dome on top, which was 68 feet thick, and the tower was 187 feet. And his idea was that he actually was going to use this to set the Earth into oscillation, and was going to be able to have wireless power available anywhere. Unfortunately, and he did get it to work similar to the one that was working out in Colorado. They didn't ever finish the dome on top. It was left just like this, and it was never enclosed like he wanted it to be. But he was able to produce some pretty good noise and everything else, and people definitely complained, but that was what he was trying to do. Unfortunately, he ran out of money, and at that time, J.P. Morgan, who had invested in mostly Edison's power grid, realized all of a sudden, if I keep putting more money in with this guy, I'm not going to make any money, because he wants to give it away free. So his investments in Edison's power grid wouldn't have been worth too much. Okay, because of the fact that J.P. Morgan wouldn't give him any money, he couldn't get any money from anybody else, and this was finished in 1904. He did get to do some things with it. In 1905, Tesla had a nervous breakdown. It was his second nervous breakdown. He'd had one back in college when he lost all of his money gambling. He also ended up having a nervous breakdown. Well, he had one in 1905. Now realize he was 49 years old, and there are numerous biographers, including a couple of them that I've got books here, that feel like that probably, even though he lived to be 86, that 1905 or age 50 was his downfall, because it severely, if not from then on, he was essentially broke. He couldn't get anybody to give him any money. He was not successful with his free power thing, and he really and truly wasn't able to do a whole lot more with it. Now you realize also there was a Supreme Court decision about that time that actually took away his claim to the fact that he was the father of radio, or the inventor of radio, and gave it to Marconi. The reason that happened was because at that time Marconi had sent signals across the Atlantic Ocean. He was fitting ships with his transmitters and receivers, and it was really Marconi was doing fantastic. He was making money as fast as he could get it. That's one thing that's kind of interesting. Tesla was never a businessman. He didn't want to be. He wasn't interested in business, and he essentially, just blew his money without being able to really accomplish what he wanted to accomplish. So what I'm trying to point out is that he was broke. The other thing is he began to do things which a lot of people didn't agree with. This was a quote that he actually, and we've got the article that was written in 1919, where he claims that Hertz would be shown as a charlatan, that he wasn't really, he hadn't invented anything, that the Hertz idea of electromagnetic radiation was no good. He also attacked Einstein, and he claimed in Colorado that he had generated enough voltage to split atoms, and when he did, nothing happened. And all he would have had to do was live 2 more years, and he would have seen a major splitting of atoms, and what energy was that you could get from that. In 1931, Time magazine wrote an article about Tesla. This was on his 75th birthday, and they really gave him a lot of credit for the things that he had accomplished, mostly the AC power and AC motor thing. And if I didn't mention it, his AC motors required at least a 2-phase AC system. And of course what we've got today is 3-phase AC, but it required a 2-phase AC system to get his motors started so that they would run. But they did not have to have a commutator, which is a big thing. His country, Yugoslavia and Czechoslovakia, honored him with several things. This is a picture of Tesla in 1937. He was 80 years old, 82, 81. And he was honored with the White Lion Award from Czechoslovakia at that time. This is a beautiful museum, from what I understand, in Belgrade, that was established in the last, I think, 10 years, 15 years, to honor Tesla for what he did accomplish. Let me just quickly tell you what he did accomplish. In 1983, there was a postage stamp in his honor. In 1954, there was an asteroid 2244, that was named for Tesla. In 1966, there was a moon crater on the backside of the moon that was named for him. The Belgrade International Airport is now called Tesla, Nikola Tesla Airport. There's the Tesla Memorial Society, the International Tesla Society. He received, now this is really something, he was given in 1917 the Edison Award, which the AIEE felt like he would deserve. If any of you are into magnetic flux density, it's now called, that's what MRI machines, they measure magnetic flux, and that is the Tesla now, the unit of the Tesla. The IEEE offers since 1976 or 96 a Tesla award. There's just a bunch of things. There's a beautiful monument, and I have seen it at Niagara Falls, that is a monument to Tesla and is actually a statue of Tesla. Well, you know how that goes. And I think most of you will recognize the Model S, which is also honoring Tesla. He was an interesting guy. If you read this man here, this John O'Neill, that wrote this book, he wrote the book in 1944. Tesla died in 43. He wrote the book in 44. He knew Tesla, and Tesla told him at one time that he felt like if anybody was going to write a book, that he would prefer that it be John O'Neill. John O'Neill called him a prodigal genius. Another lady who was a science writer wrote this book here in 1981. Her name was Margaret Cheney, and she, like I said, was a science writer. Again, she called it Man Out of Time, and she felt like that if he had lived even another 10 or 15 years, that he would have done a whole lot more. And she said if he lived today, that he would be recognized as probably the greatest inventor of all times. I just basically mentioned this, but this is an article in this magazine on Tesla's death ray. Believe it or not, he had the idea that he could take miniature particles, and he's talking about small tungsten particles that were probably the diameter of a human hair, give them so much energy using Tesla coil type accelerants that he could knock airplanes out of the sky with a particle that was only the diameter of a human hair. And let me just tell you something. When he died, we still to this day don't know what happened to all of his papers, because they immediately went into his hotel room where he had his stuff. What has been released to the Belgrade Tesla Museum is probably a small percentage of what actually was taken out of that room. And to this day, we don't know all that the FBI supposedly has the majority of those, as far as we know. Do what?
An MIT professor named John Trump analyzed the papers that the FBI confiscated, who is the uncle of our current president.
But even he didn't get to see all of them.
He didn't see all of them.
They were in Dayton, Ohio at the time he got a chance to look at them, and even he didn't get a chance to see all of them. This book here, which is on loan from Mel here,
That's yours now.
called The Life and Times of an Electric Messiah. And he was considered at that, when that book was written, as being somebody really special. In fact, there was an article that came out on the internet that called Tesla God and Edison the Devil. And they were determined that Edison had created the worst environment that Tesla could have ever been exposed to, and Tesla overcame it. But it's kind of interesting. Now let me throw one more thing interesting to you. There was a theory that in 1937, when Marconi died, that Marconi got Tesla, who died in 1943, on his 144-foot yacht, and they went down to South America and built a underground laboratory. And so Marconi faked his death in 1937. He took Tesla with him down to and built this underground laboratory, and they were studying anti-gravity. And there are pictures that have actually come out of South America that supposedly show some spacecraft that are anti-gravity space ships that they say came out of that laboratory now. When you get so much attached to one man, like I read all of the different things that he claimed that he did, it's just amazing. The only word I have seen that really and truly explains who Tesla was is the word enigma. And he was an enigma. There's no doubt about that. But he was an interest. And oh, one other thing that of interest, for what it's worth, Tesla had 112 U.S. patents, and Edison had over 1,000. So there are a lot of people still say that. But Tesla's criticism of Edison was that if Edison was looking for a needle in a haystack, that he had the patience to sit there and go through every single piece of straw in the haystack and find the needle. Where Tesla said he could save Edison 95% of his time with a magnet. So the two of them argued almost their entire lifetime. It was just very fascinating. If you really and truly have the time and want to dig into what this guy did and didn't do, we've got books in the library. And Mel, thank you. I will accept the donation and make them available for people that are interested in following up on Tesla. And
What about the Nobel Prize?
About-
Nobel Peace Prize?
about what prize?
You said something about the Nobel Peace Prize.
He never did get a Nobel Peace Prize. He and Edison were supposed to share one, and something happened, and nobody would ever tell. The Nobel Prize was given to somebody else that was originally supposed to go to jointly Edison and Tesla. So something happened. Nobody will ever know.
Was there any certain part of his work that caused it to be kept secret all this time?
The death ray was a big thing.
So somebody must think it would work.
We don't know. His idea was he found out that he could take a vacuum tube that he could accelerate particles out of, leave one end of that vacuum tube open, and by using a very high pressure airstream to keep it where it could be evacuated and the vacuum could stay in it, that he could actually have that accelerate the particles. And he was going to accelerate them with 100 million volts. And if you know some of these TV sets, you get up to 15,000 volts, you've really gone a long way. But imagine 100 million volts. He felt like he could take these little particles and give them so much energy that they could do anything.
Dave, why did the FBI want those papers?
We don't know. We have no idea. We don't know why some of them have never been made public.
Well, keep in mind, this is right on the verge of World War II. So, you know, the speculation is there was a lot of stuff they didn't want to fall in.
Well,
You know, why they're still sitting on them, that's the issue.
believe it or not, in 1937, he actually invited the Soviets to bid on his death ray. And they were interested. I don't think it ever happened, but he actually allowed them to bid on doing it. Let me just mention two other quick things. He was an interesting guy. He never married. He felt like that would have kept him from accomplishing what he did. But his last 20 years, he fell in love with pigeons. He would walk 8 to 10 miles a day. He counted his steps as he walked. He wouldn't step on a crack in the sidewalk. He dressed immaculately. He would put on gloves and like a tuxedo to go out and feed the pigeons. If for any reason he couldn't get out to feed the pigeons, he would hire somebody. He had a Western Union boy that delivered Western Union telegraphs that he would actually hire to go feed the pigeons. He fell in love with a pigeon. She was a white pigeon with little gray tips on her wings, and anytime he would whistle, she would come in the window of his hotel. And by the way, he got thrown out of 4 hotels because of the pigeons. He let the pigeons come in his window, and obviously they didn't keep things very clean. But he fell in love with this pigeon, and he said his love was as good as any man could ever have for a woman. I will leave it at that. Thank you very much. It was very interesting. Willie said that I really ought to do this in 2 or 3 different programs, but I hope I hadn't compressed it into too much.
You did
Thank you.
good.
Thank you.